I'm really excited to be here because AI is something that everyone hears about all the time. You hear so much talk about it, but I think it's really a struggle to understand what the technology even is and what it can do. So I am always happy to be my nerdy self and share some information about how AI works, which is something I'm going to talk about today, and also how it can be used and be useful in general for the international development field. Can I switch over to my slides? We can start.
It took.
Sorry. Great. Okay. All right. So just so you know which parts you can sleep through or whatever, the first, what I'm going to talk about today is I'll give you a little bit of background about myself and why I'm even here. I'm going to talk a little bit about what AI actually is. I'm also going to, like I said, get into how AI works, because I do think that that's very important for people who are going to be working with AI to understand how the technology works. Then we're going to talk a little bit about some of the considerations to think about when you're putting AI to use, which includes both barriers and also some topics to think about. And then lastly, we're going to go over about 5 case studies related to AI that I think cover a broad range of fields and applications, so I think it will interest everybody here. Okay, wow, that's big font on here. A little bit about me. So my background is academically, my background's in engineering. So I studied information systems, computer science, informatics. I'm a Columbia University grad, so I'm here in New York. I have not worked as a software developer though, and that was for a reason, because one of the bits that I was really passionate about when it came to technology for development was being able to put these products to use and really understanding what a good, useful product looked like. And so I ended up actually working in design, which is what I have been doing more or less for the past nearing a decade now. And right now, like I said, I work for Dahlberg Design, which is a full-service human-centered design firm. I lead a lot of their tech work in terms of visual design work. Previously, I was at the World Bank. I was an ICT and innovation specialist there for a couple of years. So I'm very familiar with how massive organizations like the UN, et cetera, work. And I'm also faculty. I used to teach. I taught a course with UNICEF, actually, at Parsons School of Design, their Tech for Development Studio class. This is in 2014. And I also taught a summer school class in Copenhagen. So my background in AI. My first exposure to machine learning and all these different topics was in graduate school. I studied informatics, and specifically its application to global health. So back then, when I was studying it, it wasn't nearly as advanced as it was today. I mean, the field of AI generally has blown up so much in the last, I would say, 3 or 4 years. Massive advances have been made. That's why we've been seeing so many really cool tools coming out. So everything was really different when I was in graduate school. So over the past year, I spent a lot of time both outside of work and a little bit inside of work, taking a bunch of coursework, working on my own little projects to really understand deep learning, machine learning. Oops.
Thanks, Auntie.
Thank you. To really understand deep learning, and so I actually can build all this stuff, so I'm not just making it all up. I actually do know what I'm talking about a little bit. I feel like I have to qualify that because there are so many people out there who maybe don't really know about it, but are just talking about it. And most recently, I both created and taught the very first AI for International Development course at Tech Change. I don't know if you guys know Tech Change. You should check them out. They teach a lot of really great online courses for tech for development specifically, and AI for development is one of them. We just finished it in May, but I don't actually know when the next time they're going to run it is. Maybe later this year, maybe next year, but email them and find out. They will tell you. So I am going to talk a little bit about what AI actually is. So these are just some headlines that I pulled from maybe the past week, 2 weeks. You can see that there are all kinds of really grandiose headlines saying, AI is going to attack fake news in the Mexican election, which is a pretty grand statement. I don't actually know anything about that. If anyone does, we can talk about that later. But you can see AI is a really hot topic. There's a lot of hype around it. Everyone's talking about it, but I feel like very few people know what its capabilities actually are and where we are in terms of research. So artificial intelligence is a very broad term, actually. It refers to a whole variety of different tools and algorithms and models and methods that really just, they do their best to imitate human intelligence. And that means a bunch of different things. That means you can how to train an algorithm or a computer to do human tasks like see. So, do computer vision, which is like look at a picture and understand what it is that you're seeing. Another task is speech. So being able to hear a piece of audio and understand what's actually being said. And then decision making. So taking a bunch of pieces of information and making, the best decision around that. And it includes a lot of different terms: machine learning, deep learning, neural networks. I'm going to get into what they actually mean in a minute. Because first I want to talk about this gradient here. So in the space of AI, and especially in the research space, they talk about AI on a general spectrum. Should I turn off the lights? I don't know if you guys can see this. Can see it? Okay. So you can see here there's sort of a spectrum between what we call weak AI and strong AI. Weak AI, so this, by the way, is not like a formal definition. This is just a rough approximation of how people in academia would see it. Weak AI, it starts with something that's incredibly basic, which we definitely have right now. It's just, it's basically an algorithm or a program that can take information, understand it, and then make a decision based off of it. It's very direct. It's cause and effect, in and out, nothing crazy or fancy. Then you move it up a little bit, and you get to AI that has limited memory, which means it can maybe remember some facts, like if you present it with a sentence, it will remember what the subject of the sentence was beforehand, so that later when you say, a verb, it'll know who you were talking about before. That's limited memory. Then we get into a little bit more complex AI, which is the type of thing that we see in movies and what we think of when we think of AI, which is, tools that can understand what humans are saying and thinking and even feeling. And then, of course, getting to like self-aware AI, which is the killer robots that we all see in movies, But I have some good news, which is that, well, it's good and bad news. In terms of where we are right now, we're actually about here in terms of research. We have a lot of really great reactive AI that we can go out and use right now. It's available out if you Google it. You can use stuff for yourself today. And researchers are starting to work on the limited memory. So we have started to make some good progress on being able to have machines and algorithms remember bits and pieces of information, but not very much right now. The term artificial intelligence is also a really broad term. This is how I would explain it to people. If you took this out to MIT or Stanford, I don't know, I'm sure some professors might see it a little bit differently. But in general, the one thing that I would like to make sure you guys get out of this diagram here is that really a lot of artificial intelligence is based on machine learning, which is essentially training a machine to learn for itself. And I'll get into that in a little bit. You can see all these subtrees come underneath the title of machine learning. And then everything else, so that includes all the scary killer robots that we hear about, that goes under a term that I call cognitive computing. Honestly, it's kind of a meaningless term. Cognitive computing doesn't really mean anything at this point. It's kind of a marketing term people use. So if you hear somebody say oh, I have this cool cognitive computing tool, do a little more research and see what it is they're actually talking about, because technically that doesn't really mean anything. And then if you look at it from this spectrum that I talked about earlier, you can see, well, actually, maybe you can't see so well, but really, most of these machine learning techniques are a very basic, weak form of AI, and only here do we start to get a little bit orange where we're able to have that memory. This is pink because this is, basically doesn't exist as of yet. We're working on it as a field. So now I want to get a little bit into how AI actually works. And I'm not going to get into the technicalities of it, so I'm not going to talk about code or anything. I'm also not really going to touch on the math because it's primarily math, actually. But I do think it's important to understand the base technology that underlines AI. So here we have a picture of a cat, which everybody in this room hopefully recognized as a cat. If you wanted to write a program, so a little piece of computer code to identify what this picture was, the way that you would do it traditionally is, write a bunch of if-then statements. So here's this picture, look at every single pixel in this picture, figure out what it's looking at. If what you see has brown fur, if what you see has the little triangle ears, if what you see has, green eyes and maybe 3 or 4 paws that you could see, all these conditions, then it's a cat that you're looking at. That's how you would traditionally define a program that would look at this picture. But now let's say we have 2 different pictures of a cat. if you use that same program that you had for the first cat, it probably actually wouldn't work on this because you probably would have defined this as it has brown fur and it's maybe a little skinnier. This one's kind of chubby. So I don't know, it's a little bit of a different cat. Basically, you would not be able to recreate and use that same algorithm to identify this cat. And that's sort of the fundamental reasoning and the problem behind AI that people were trying to solve by building this tech, which is, it wouldn't make any sense for us to create tools that can look at images or understand speech or anything and have to hard code everything because that's an impossible task. We cannot possibly do that for every object in the universe. So instead, the way that we approach it is through machine learning, which is essentially giving the algorithm just a bunch of different examples and having it learn for itself. So you can see here, I have a very small data set here, but typically when you're training a machine learning algorithm, you would give it lots and lots of examples. And it comes from the same idea of how humans learn. So if you have a small child, if you wanted to teach it what a cat was, you're not going to sit there and say, okay, cats have, fur and they have like triangle ears or whatever. The way you probably do it is every time you saw a cat, you would say, look, that's a cat. Or if you went to the zoo, you'd be like, wait, that's a tiger, which is a big cat, or whatever. That's sort of the basic idea behind how machine learning works. It's to mimic the way humans learn. And in doing so, making it a lot more powerful because then it's not on you to have to define something, it's on the machine to learn it. So here, I have a whole bunch of different examples. You can see that they're labeled cat or not cat. So if you give a machine, or an algorithm rather, all these pictures with the labels saying, okay, this is a cat, this is a cat, this is not a cat, this is a cat, then it can sort of start to learn. Like it'll start to look at the patterns between the images of the cats and find out for itself, like, okay, these are all the similarities that are here. This is how I know what a cat looks like. That's called binary classification. This isn't really important, but I think it's useful to know. Binary just means that there are two categories, cat or not cat. There's also multi-class classification, which you can also do with this form because you can ask the algorithm to look at not just here's a picture of a cat. You can also say this is a picture of a house, so learn to recognize houses as well. This is a dog. That's a bicycle. So in this way, you can have it recognize a lot of different classes if you're trying to get it to do recognition. So, sorry, let me go back. So here, you can see that we've also given it a bunch of images with labels. That's called supervised learning, which basically means you're giving it the correct answers beforehand and it can learn from that. That's really useful for certain types of problems and certain kinds of situations, but there is also unsupervised learning, which is where you can give a computer a bunch of pictures, not tell it what the pictures are, and just let it sort of figure out what patterns it's seeing among this. The math is what differs behind it. It's just an entirely different approach, mathematically. But those are still, it's important to know that you can have data that's unlabeled and still learn that as well. So the way that it does this is basically by learning the different combinations of features that it's seeing together. So instead of you, like I said, instructing it as to what it's seeing, it figures it out for itself by searching for patterns. And by doing so, it learns a mathematical model. Yes?
Sorry, so AI doesn't give a criterion anymore, because so I'm just thinking of this cute little dog there on the second row. I could see that a computer would mistake the dog for a cat.
Yeah.
But how does it know that it's not a cat? Because so I give it the criterion. For example, I don't know the distance between the eyes or the shape of the face, or does the computer figure out everything by itself?
It figures out everything. Okay. It looks at all the pixel by pixel. It's going to analyze that and figure it out for itself. So you don't even need to give it features necessarily when it comes to images. For different types of data, you may have to do that. I don't want to give blanket statements like that, but for this particular problem, if it's an image, the image contains all the information that it would need. And there's a lot of math behind that, which I'm not going to get into today, but I can send some links if you're interested in how that works. So basically, it learns a mathematical model. And what that model looks like is basically based on how the human brain works, loosely. So here we have a neuron, which is a cell within the human brain. I don't know if any of you remember from high school biology, but basically the way a neuron works is signals come in through these dendrites here. They're processed by the cell unit. Something happens, maybe proteins created, whatever, something like that. And then an output signal is sent through the axon and continues on. So the electric signal goes in that direction. So the mathematical version of a neuron, which is basically what a lot of machine learning and deep learning is based on, is it's basically a function, I guess, if you want to call it that. You have a couple of different inputs. In this case, I have 3 different x inputs. You could have 1, you could have 1,000,000, you could have as many as makes sense. You put all of those inputs into a particular function that I'm going to call an activation function. I'm not going to talk about what the math is there, just know that it is a mathematical function of some kind, and it's going to output a y. And the way that you train a machine is by, so for supervised learning, the way that you would train a machine is give it the correct answers beforehand. So you say, when you input all these x's, you should get this y value. And what it's going to do is it's going to just pick some random values, some parameters for this function right here, and it's going to test it. It's going to say, okay, let's test out these parameters. Let's put all these x's in. Okay, I get this different y value. Let's compare it to the actual y value. Okay, it's a little bit too big. Let's go back and update this parameter. Try it again and again and again, and it does that until it has come up with a model that is as close as it could possibly get, which you may, it's now we're getting into stats. It's more like regression, if you want to think about it in that way. And that is how it comes up with a model that approximates the correct answer. And then when you stack a bunch of these one on top of another, you get what's called a neural network. So you see where that name comes from now. This is deep learning is basically just a form of machine learning. It's really referring to the fact that here you can see we have a lot of different functions that are stacked in layers. The theory is, although this is still technically an open research question, theory is that at every layer, the machine's going to learn a little bit more about what it's looking at. So it's going to, let's say you input a bunch of pixels for an image, like you were asking about. Layer 1, you might learn about what's light and dark. Layer 2, you might learn about what shapes things are, squares, circles, etc. Layer 3, you might start to identify some of them, like this. Put these circles together and you get a face. So it's learning more and more advanced information at every level. And again, this is still more or less an open research question, like, is this the best way to do it? But as of yet, this is the best way we've come up with being able to do it. So that's a little bit of the math, just so you have a general sense of how that works. Now, what do we do with this? How do we actually use AI tools? So there are 3 general phases of actually creating AI. The first one, actually, I didn't include this on the slide, but there is a step 0, which is have a lot of data. When I say a lot of data, I don't mean like a couple hundred pieces of data. I mean, we're talking millions of pieces of data, because the more data you have, the better, which I'll touch on in a little bit, but it is important, like super important, to have a lot of data, because without it, you cannot train an algorithm. So the first step is to train an algorithm with a lot of data that you know to be good and correct. Second step would be to test the algorithm that you've come up with, of course, with new data. You don't want to test it with the same data that you trained it with, because you're not really going to learn anything new that way. You want to go back and test it, or you want to test it, make any changes accordingly, go back, train it again if you need to, and so on and so forth until you've come up with an algorithm that is good enough to be able to use. So what are some ways that you can use AI? I don't think that there's no exhaustive list. These are just some examples that I've come up with that I think are particularly relevant. Go to this side so I can read it. So the first is classification, which is what we've been talking about in the examples I've been using, which is looking at a particular picture or numbers or something and being able to classify it within certain categories. So that would include diagnosing diseases. So if you could look at an X-ray, for instance, and be able to diagnose, yes, this has cancer, no, it does not have cancer. That's classification. Another example of that is identifying objects that you would see in a drone image or a satellite image. The next category that I've included here that I think is useful is prediction. So taking a bunch of data sets that already exist and extrapolating from that data without you having to know what the patterns or the equations are within it. So that includes forecasting the spread of disease. That's an example. Or determining creditworthiness. So if you have a customer who's coming for a loan, you can maybe look at a couple of factors about it and be able to predict, just as you would with regular statistics, whether that person's going to be creditworthy or not. Another use is translation. So of course between languages, but it can also be between different styles. So it could be taking like one style of art, say like a Van Gogh painting, and translating it to, or taking a photograph that you've taken and translating it to the Van Gogh style. And there's some apps out there that actually do that. I don't know if you've seen, I think Google released something that does the art style transfer thing there. So that's another example. And the last is creative generation, which is just coming up with new things from scratch. So art or music, images and video, which is a little bit scary. We need to learn how to deal with, coming up with a video of somebody speaking when it never really happened. That's technically possible. So something to think about for the future. But, so all that sounds really great. How come we're not doing it tomorrow? Why don't we have all kinds of awesome AI applications for international development? There's a couple of reasons. I feel like this is just one slide, but I think it actually merits a lot more discussion as to why we can't really get too much into AI just yet in the field of international development. One of the biggest reasons for it is the skills that you need. So because it's such a new field, and because programming AI is not similar to writing other code, because like I said, it's an entirely different approach to code. So just taking your average website developer and saying, build me a machine learning tool is not going to work, because they need to be trained in the math, because like I said, it's primarily math. It's an entirely different discipline, more or less. So having to train people to be able to actually build these tools is expensive, because there aren't many people out there who can do it right now. It's just a fact. There's more programs cropping up. Stanford, of course, is the biggest one that everybody seems to know, but lots of universities around the world are opening them, and they have a bunch of online classes that you can take now. But that doesn't really change the fact that they are still pretty expensive. I mean, I want to say AI engineers can go to California, Silicon Valley, and get paid $500,000, a year's salary straight out of school. So it's a supply and demand issue. There's just not a lot of it right now. The costs are going to drop as we train more and more people, but that's something to be aware of right now. It's not cheap. Can't even see my own slides. The next barrier that I think is worth discussing is the amount of data and resources that are needed. So like I said, if you want to train an AI algorithm, you have to have a lot of data. And I like to bring up this quote from Dr. Andrew Ng, who is one of the leading AI scientists in the world. He helped start the Google Brain team, etc. And he says, it's not who has the best algorithm who wins, it's who has the most data. So if somebody comes up to you and says, I have this amazing algorithm and it can, predict anything, the first thing you want to ask them is, what data did you train it on? And how much of it was there? Because if they say, oh, I polled 30 people on the street and I built this model, that's not going to be good enough. And you should know that. So having the data necessary to be able to train these algorithms is still a pretty major barrier in the international development space. As we know, big data has been a thing for a while, but we're not quite at the point where we have the data sets that we would need and want to be able to create these tools. So that's one. And then I included the word resources as well, because you also have to have the computing resources to be able to do it. So you need to have enough servers or enough, actual machinery to be able to run these advanced algorithms on. I have a little MacBook Pro, and just to do the little personal projects that I was working on, the longest time, it took me about 5 hours to run one of the algorithms. And that's, again, for a really small algorithm. That's starting to change because companies like Google and Amazon are renting out their server space. They have a lot of cloud space that you can use, but that requires bandwidth, which requires electricity, which requires internet access. So you can see there's all kinds of factors here that you would need to have in place before you can start using all these tools. And the last thing is regulatory and policy frameworks. So we don't know how to deal with all this technology yet, and that's because it's so brand new, and we don't even know what we're capable yet of at this point. So it starts everywhere from, how are we going to collect this data? What rules are we going to make around collecting the data, to privacy and security? If you're collecting data on people, how much access should they have to it? Should they know that their data is being collected? Things like ethics. Shouldn't people know how you're using their data? Questions like that, there are still no clear answers to. Maybe to you or me there might be clear answers, but on a broader scale, from governments, from industry, from organizations, we haven't really come up with a set standard of ways to approach this topic. And to build on that a little bit, some considerations that you would need to make if you're going to use an AI tool include thinking about the fact that when you're working with large sets of data, your algorithm is only going to be good, like I said, as the data that you're building and using to build it. And I say that because if you don't have representative and diverse data, then your algorithm is also going to be biased and not representative, right? So an example is if you want to create an algorithm that's, predicting people's behavior in some way, but you only included people from the US, you didn't include people from any other country, is it really fair to go out and use that in Europe or in Sub-Saharan Africa when you don't really have, you never included that information in training the algorithm to begin with? There are a lot of really good case studies out there to highlight and exemplify how that can really impact the way that your tool works. A really good one that I recommend is ProPublica, published, I want to say last year sometime, or maybe earlier this year, a really great case report on the US criminal justice system, where they are using algorithms, I don't remember in what state, I don't want to call out any state in particular, but somewhere, and the algorithm that they were using had a very high rate of pointing out criminal activity among Black populations than others. And this wasn't really, that's not really fair to say that about a particular group of people, but just because that was the data that they had coming in, it was a bias that was reflected in the algorithm. And they caught it quickly, and they were able to say, okay, maybe we need to work on this a little more before we go out and put it to use. But they wrote a pretty extensive case study on that, so I would recommend taking a look. The last thing I'll say is that there are tools out there that can help with ensuring that your data isn't biased. I saw a Fast Company article, I want to say yesterday or the day before, saying that some university had released a tool where you could run your data set through it and it will try to identify certain biases that exist in there. So using tools like that is going to really go a long way to make sure we're not including bias and discrimination. And the other consideration that's super important is privacy and security. So as we all know, Facebook and Cambridge Analytica got in a lot of trouble recently for sharing data about their users to, well, Facebook shared data to Cambridge Analytica and a bunch of other firms. But I think that news story, which we did study in the course that I taught recently, was really important because it showed how much the public is now really interested in this topic. Before, I think if you had said, no, does the average person care about what their data is being used for? I think people would have said no. But with this news coming out, it's pretty clear that everyone was really upset. Nobody really knew what was being done with their data. When they realized it could have affected elections, people got really riled up and upset about it. So really making sure that consent and adequate protections are put in place for any data that you're going to be using for any project, but especially for something like AI, where you're running it through an algorithm that you can't necessarily even describe to somebody else, is especially key, because we're at a point right now where we are just at the beginning of how much of the different ways we can use AI. So now is the time to be able to really address our privacy and security concerns before it becomes too late, before we end up with another Facebook or Cambridge Analytica situation on our hands. And the one thing I would like to point out is within the UN system, UN Global Pulse actually has a really great set of privacy and data protection principles. So I really encourage you to go to their website and check it out. So anytime you're going to work on a project with data of any sort, really, but especially any big data or any AI application which relies on big data, definitely take a look at those principles and put them to use in your work. 15 more minutes. Okay, so now we're going to talk a little bit about case studies. I do want to preface this with there isn't a lot of really good, well-documented case studies out there. And that is because we don't actually have a lot of good examples of how to use AI in international development, because it's such a new field. Like I said, any examples you find will be maybe on a smaller scale. Certainly no massive examples like there's no Siri or Alexa equivalent for international development, right? Not yet. Maybe one of you will come up with it. I don't know. But the first one I'd love to talk about is an app called ResApp, which is actually based out of Australia. And they're really interesting because they did what a lot of people talk about, but don't never actually do, which is create a smartphone application that can actually diagnose respiratory conditions just based on the sound of a patient's cough. So basically, you cough into your phone speaker, and it sounds crazy, but the algorithm can actually find very small, nuances within that cough and be able to fairly accurately indicate, whether you have a particular type of disease or not. And they've run clinical trials on this. This isn't just like them talking it up. It's actually been clinically proven to work really well. And they trained it with, and I don't know the size of it, but definitely in a very extensive, huge set of patients coughing and, the matching diagnosis that went with it. And the algorithm was then able to really come up with like a very advanced mathematical model to be able to determine, okay, if the auditory file looks like this, then it's more likely to be this diagnosis. So you can see here a snapshot of the app and the way it looks. It's not publicly available. I tried downloading it, but you can't unless I think you have to be part of their clinical trials or maybe just get special permission. I don't really know how it works. So it's not available openly. But I think it pertains to international development because they recently agreed to the Gates Foundation's global access objectives, which I admit I'm not super familiar with. But basically, they're trying to use this app to be able to be used around the world in the form of an app called Pneumophone. And I couldn't really find any information about Pneumophone out there, sorry. But it's in their plan and they're gonna make it work. So hopefully that's something you will see coming. And I've included the links to all of these examples at the bottom so you guys can go and check it out for yourselves. Another example that I think is super interesting is using AI to tackle illegal poaching and wildlife preservation, I guess, around the world. So there's a company called Rainforest Connection, which I actually heard speak at an event not too long ago. And they initially started in about 2015. They took a bunch of different feature phones, so just regular cell phones, of park rangers and people who spent or lived near rainforest areas, and just asked them to participate in their program so that they could listen into all the different sounds coming in from the rainforest area that they were in. And by listening to that, the sounds that are coming in from the feature phone, they were eventually able to develop a pretty advanced algorithm that they actually made even more advanced by putting in some machine learning into it and redoing it. That allows them to really finely identify when somebody is cutting down a tree, or if they hear gunshots, that's something that will register. And I was reading, it's actually become powerful enough to where it can identify when a silent animal comes in. So let's say like a tiger comes in, walks through, you can't typically hear that on a phone. You can hear all the other birds freaking out or like other creatures running away. And it's been able to learn from those patterns when a giant predator is coming through, which I think is really cool. And the machine learned that. It wasn't something that they taught the machine how to do. With all of these, it's been the machine analyzing a lot of patterns and building mathematical models based off of that data and learning that way. Their website says they can detect chainsaws a kilometer away, which is pretty amazing. I can't personally vouch for this, of course. Yes?
So for this one, like for example, that means that they are listening to everything that goes onto your mobile and you give them full access to.
Well, so they originally started using people's, but now they have just their own proprietary phones that they use. So it's not like your personal cell phone anymore. Although if you want to, you can opt in and you live in that area. If that's something you want to do, you can do that. But they rely now on a network of a bunch of phones, and that they actually have. In this picture, you can see they're sort of attaching speakers and all to the rainforest. They have a pretty big, extensive network of them throughout. It started off with phones, and now I think they've moved to both a combination of phones and actual speakers. It's a good question. I wouldn't be happy if my phone was constantly listening in on me either. So that's a slightly different example. A third example is tracking down child sex offenders, which we can all agree is a horrible thing, and we should be doing a lot to stop. That is Ashton Kutcher, because it's his organization actually that is using some of this technology. So there's a doctoral candidate at the University of California at Berkeley. Her name is Rebecca Portnoy. She developed an algorithm that actually goes through and scrapes information from online sex ads. Something that is very unpleasant for a human to do, so it's really nice that a machine can do this for you instead. And basically, it starts to look at tons and tons and tons of these ads online and scrape through and look for patterns within these ads so that they can identify people who are obviously like pimping out children or, just like have a lot of different ads. And they actually take it a step further where they're able to track their cryptocurrency addresses. And in that way, they're able to really tie groups of traffickers together and also be able to ultimately get some direction for identifying them. You can't identify somebody based on their cryptocurrency wallet because that's part of the benefit of having anonymous online currency, but it certainly helped. And I don't have any specific information of how it's being used or how extensively, but I do know that law enforcement is starting to at least try this out within their organizations, I imagine in California, which is where this is based. And the NGO that I mentioned earlier called Thorn is also starting to experiment with it. Thorn is an anti-child trafficking organization and they actually hired Rebecca recently. So I think you should keep an eye out on them and see some really cool stuff coming from that organization. The next two examples are actually from the UN system. So I think that will be of particular interest to you because they're your colleagues that are working on this. So one is the UNICEF Innovation Team, which I'm sure you guys are familiar with to some degree. They have a program called Magic Box that just works with a whole bunch of different data sources and does different things with the data. But one particular machine learning project that they're working on is mapping schools. And the way that they're doing this is they're taking very high resolution satellite imagery and running it through a deep learning algorithm, which, as you remember, is more sophisticated than just like an everyday average machine learning algorithm. And they're able to train that system to be able to identify where there are schools. This is a pretty tough problem because I work a lot in health, but even with clinics or schools, it's almost impossible to map every single clinic or school in the country, right? Because they're located in places that are hard to find sometimes. So if you can take a satellite image and be able to have a machine that's really able to dig through all the data, start to look for patterns of pixels or whatever it is that it's finding within the satellite images and be able to tell you with a fairly high degree of certainty that there's a pretty high probability that there's a school here, that makes your job a lot easier if you're somebody working with the Ministry of Education or if you're a UN organization looking to fund schools. There's a million different ways to be able to use a tool like this. I don't know if it's open to the public yet. I'm sure you could reach out to your colleagues at UNICEF and ask if you could see a little bit of it. But they are working with an organization in DC called Development C to build this, and I believe with UC San Diego as well. And there's the link at the bottom. It's unicefstories.org/magicbox/school mapping. You should be able to see a little video that goes over this. And the last example is from UN Global Pulse, which, as you know, is the big data organization at the UN. Their Pulse Lab in Kampala in Uganda just finished creating this pretty cool machine learning tool that actually scrapes data from public radio programs. So all of us have, listened to the radio at some point, and you always hear programs where people are calling in and sharing their opinions and their stories, etc. And there's a lot of that goes on. So what the Pulse Lab team did is use a tool that transcribed a lot of those conversations and translated them in cases where they need to be translated. And they were able to use those to sort of look for patterns and bits and pieces of information about the SDGs based on the conversations that people were having. So down here is an example of one little snippet that they used to run their analysis, which is, the listening part doesn't work, but it's basically a woman who had called in to talk about the fact that people were not really using mosquito nets in her neighborhood. She was just calling an event. I guess the radio DJ was like, hey, what are some health problems you're seeing? And this woman called in and was like, oh, they give us all these mosquito nets and my neighbor used it as a chicken coop and I don't really understand why, she was complaining. But that's valuable information because you just learned about a way that somebody's using a mosquito net that doesn't make sense to you or me, but probably makes sense to them, right? So if you can scrape that information and use that to be able to sort of pinpoint the direction that SDGs could go in, or at least help you figure out, what actions you could take to be able to better fulfill the SDGs. Yes.
But I presume they're doing a content analysis.
Yes.
So they're not just saying mosquito net and then it arrives there, but it's like, I don't like the mosquito net, and then it's taken into context.
Exactly. Okay. Yes. So they're just taking in whatever conversations people are having. They're not going out and sending requests saying, hey, everyone, talk about mosquito nets. It's just whatever is happening on public radio, they're just scraping it and then analyzing that for the content, exactly as he said. I don't have any more specific details of how the algorithm works, probably because they're still working on it, so it's kind of in a wraps. But as this develops, I think it could be a really useful tool, not just for radio content analysis, but you could use that for Twitter analysis or use it for any type of data analysis that just numbers too much for humans to be able to tackle. And that really is the promise of AI, right? It takes tasks that humans would be able to do if we had superhuman powers. So if we could listen in on every single radio conversation that goes on in all of Uganda, we probably have a great idea of what people are interested in. But we can't because we're just people. The machines can do that much better than we can and learn similarly, not quite the same, but similarly in the way that humans learn. And as we get more and more and more advanced with that technology, that's where the magic comes in. That's where you can ask a machine to do something that you ordinarily by yourself couldn't really get done. I think that's it for my slides. Yeah. Okay. So I think I'm a little. Oh, I'm just in time. Any questions from you guys? I know that was a lot. Sorry to like run through it.
First of all, thank you.
Yeah.
Yeah, I have a question about causal analysis.
Okay.
Like in terms of, I'm in health too, and a lot of the traditional health research is done by, you have a hypothesis and you test it, it's statistical, and there's a causal kind of thing.
Yeah.
With machine learning, which I guess is starting to be used in public health,
Yeah.
you do all the data and then it finds associations, but then where is the causal, and is there any causal analysis that machine learning can
It can
help with?
definitely do causal analysis,
Okay.
but I think the important thing to remember about machine learning is that it works off of probabilities. Very similar to, to the way that you would probably be doing your analysis generally. It's not going to, it will give you certainty. So it'll say, this tool is 85% certain that there is a link between these two factors here. That I feel like that's a point that gets overlooked a little bit. There's very rarely anything that's 100%. So a tool that's going to give you an answer isn't going to say, I am 100% sure that this is the answer. Instead, it's going to output a probability for you. And what you're presented with is probably the highest probability, or maybe some of the highest probabilities, if that makes sense. So it's going to give you, it still gives you room to be able to look at it from your own perspective and say, okay, well, this is what the machine saw in the data. Does this match what my real world experience is? And again, go back and look at the data. Is the data including some of these causal factors that you think might be at play here? Are they missing from this? And I think adding that human element to it, which again is also a really important piece of all this, is able to just make your job easier in some ways, to not make you have to crunch those numbers on your own, and also crunch a lot more numbers than you could on your own.
So we're opening up for questions. If you could give us your name and the team or organization you're with, that would be lovely for a bit of context here. And we're going to collect a couple of questions. Is that okay?
Sure, that's
And deal with them. So questions. 1, 2, and 3. And we have 3 questions online as well.
Oh,
So
great.
let's do 3 in the room and then we'll swap out for the next one.
That sounds good. Okay. Do you want first?
Yeah, thank you. My name is Sarah Rentals-Smith. I'm currently at MIT, but worked for 8 years at the UN before. And so I'm curious, when we talk about international development, governments everywhere, but particularly in sort of cash-strapped environments, could see this, right, as a really sort of huge resource and opportunity.
Totally.
But I was wondering what your thoughts are on kind of like the promises and perils of governments adopting AI, and you talked about justice, but in these particular contexts, what the opportunities and challenges are.
I think what I would say to that is the same as I would say for any technology, which is tech is just a tool at the end of the day, and it's what you do with it that matters. So yeah, a country like that could totally use it to help all their people and do a lot of great work, but just as easily use it to track people and be able to, tell when somebody is dissenting against a government, something like that. For every good use case, there's a bad use case, and I don't think that there's any way for any of us to really know how that would go. I think that really comes down to policy regulations and making sure that there are standards, both for ethics and also just for use generally in place before, like I said earlier, it gets too far advanced, because this is the point in time where we would really need to stop and think about this before we, let things loose and let everybody have at it with all this technology. So sort of a cop-out maybe, but a true answer.
I'm Token from the International Fund for Agricultural Development, which is a specialized UN agency. In the UN system, there's a lot of talk about how artificial intelligence and other frontier technologies can help us meet the SDGs and support countries. But there's also quite a lot of concern about the fact that so far artificial intelligence is very much in the hands of which countries and which people in which countries. So it could actually ending up exacerbating existing inequalities and have a negative effect. So my question is, what do you think? What are your thoughts on what could be done to ensure artificial intelligence good?
Yeah.
And then if I may, just a quick question on how far down the scale in terms of going towards the human-like robot are we? Because I was, for example, at this Unleash Innovation Lab recently, and there was a robot that should answer some questions, and we all thought that the robot could actually make up the answers, which was not the case. It was just pre-fed with the questions and answers. So, but one day it will come, right? Somebody will take over and write all our UN speeches. So we don't have to do that.
Do all of our jobs for us, right? We all go on vacation.
How far away is that day, basically?
All right, so I will tackle your second question first because I remember it. So we're not as close, I think, as we feel like we might be to having robots that can be sentient. And the reason for that is like I said, remember that, I can pull it up if you want me to, but if you recall that gradient between weak and strong AI, we do not right now have the technology for machines to be able to really remember a lot of things. So we have brains that store memories as humans. Computers have memories in the sense that they can remember bits of information, but remembering it in the context of something and remembering, how it pertains to other information, that's something we're not really good at just yet. And there's lots of research that's being done on this right now, because basically the person who is able to sort of crack that code is, they're going to be the richest person on the planet probably in the coming years. So there are, universities are putting a lot of money into advancing AI research in that way. But as of today, we don't have that technology. So unfortunately, no one's taking your job. Maybe fortunately, I don't know. Maybe you want to go on vacation. But so that's the second question. And one more point. When you said that they fed that robot information, I think that's also something really important to remember. There's a lot of hype around AI, like I said before, and there are lots and lots of people who will try to pass very basic existing technologies off as AI and just charge you like 8 times as much for it, So that's something you have to be wary of, which is true for any technology or anything in the world, really. But that's why I wanted to touch a little bit on how this tech works, because I think it's important for you to know that, so you are not having the wool pulled over your eyes when somebody is saying that stuff like this works. And then your first question was the disparity, right, in education. That's a really good question, and it's something that has come up lots and lots in a lot of papers and conferences, et cetera, because you're right. A lot of the graduates who are building these tools right now, like I said, are from Stanford or from Oxford or Cambridge. They're from the Western world. But that is really starting to change, because Dr. Andrew Ng, who I quoted earlier, he's actually been really pushing the democratization of AI education in a lot of ways. He founded a company that I believe is called Fast.ai, which is an online training course that people can take and learn all these deep learning methods and machine learning methods to be able to learn it on their own and then put it into practice as they go out there. Because like I said, you can learn computer science at most universities, I think, around the world now, but learning machine learning and deep learning is pretty much a separate field, and it's related, but it's still within computer science, but it's separate. So there are a lot of efforts underway to make this more accessible and available to people. In fact, that's how I did it. I didn't go back to Stanford and get a master's degree. I just used what I knew from before and did an entire specialization through online classes, and it was a lot of work. I mean, it was, I want to say 9 months, 10 months of straight intensive classes. It wasn't easy, but it's possible. And as we get more and more people out there who are able to do this, hopefully they're going to be taking it back to their home countries and starting programs at universities. Just the same with any discipline. But I do think there needs to be a concerted effort for that, because you're right, we do run the risk of the Western world having control over that.
Can we actually do some online questions?
Yeah, of
if that's
course.
okay.
Yeah.
If you could.
So this is up to you. It's 4 questions. Do you want to back and forth?
Maybe one at a time.
All right, one at a time. So first of all, thank you for a wonderful
Of course.
presentation.
Thanks.
Everyone online really enjoyed it.
Great, I'm glad you did.
And we have a question from Nuri, which came pretty early on,
Okay.
asking, do you think it is possible to classify formal and informal constructions with AI?
I don't understand the question. So formal, informal constructions of what?
That's the question. I will ask for
Can you just ask for
clarification.
some clarification on what
Yes.
she means by that? Thank you.
I will. So in the meantime, Carla Gomez is asking, data is the basis for any technological application. How to get that data? What mechanisms exist to generate an ecosystem that facilitates the collection of that data?
Man, if I had those answers, I would be all of your boss right now. That's a really complicated question, because data collection, as we know, is very hard, especially in areas where you may not have good connectivity or enough resources to be able to go out and collect the data you need. So the short answer is, I don't know. I don't have a good answer for you. I think it's going to require a lot of creative thinking on all of our parts. And more than anything, it's going to require a really focused approach and a commitment to it. So you can't just say like, oh yeah, as you do this project, make sure you're collecting some data and then kind of leave it at that. I think it's really important to establish frameworks to know exactly what data you're collecting. Check in on it every now and then. See like, I want to see this data, like what's the quality? Because data quality matters too. You can't just collect like one number about every little bit that you're looking at and expect that to be a complete data set. It needs to be representative. It needs to be extensive. And so working with statisticians who you probably already have on your teams, working with data scientists, working with M&E folks. I mean, they're the people who handle all this data. I think at the end of the day, using all those different resources together, you'll be able to come up with a strategy that best works for your industry and your organization. Yeah, that's the best answer that I could.
Can I make an addition to that? Is that
Yes,
okay?
of course.
2 points. One is there's another resource that's important for UNDP colleagues, just in case that colleague is for UNDP, which is a guidance note on big data, privacy, ethics, and security from the UN Development Coordination Office. So that applies for all of us. And the second is you mentioned AI being such a hype.
Yeah.
And there has been another hype that's still ongoing about big data.
Absolutely.
And for solving algorithms, we need huge data sets, right?
We do.
But very often, big data needs to be grounded in a ground truth. We need big data to identify to what degree big data sets are reliable and can be verified. So that is another question that you need to ask your data. So just going back to your point, you need to work with statisticians, but sometimes it's just not enough to just look at the big data sets available.
Yeah.
Can I go back into the room with a question here and then we route back? Yeah.
Sure.
Can you please elaborate a little bit more? I don't want you to go into details, but about the strengths and weaknesses of supervised versus unsupervised learning, and if the examples that you provided, that are relevant for the developing world, to which category do they belong?
Good question. I believe all the examples I gave were supervised learning examples, simply because in terms of where we are in AI research, supervised learning is by far what we're better at right now. Unsupervised learning exists. There's definitely lots of methods to be able to categorize uncategorized information, but I would say that in terms of strength, supervised learning is definitely much more further advanced. And really the only difference is it's more about finding a pattern within data. If you're not sure what sort of pattern you're looking for, that's what unsupervised learning is good for. Supervised learning is good for any of the other use cases we talked about. And often the difference is just labeled versus unlabeled data. So if you don't have a labeled data sets of correct answers, if you're trying to solve a problem that has correct answers associated with it, then supervised learning is going to be the best approach. And most problems that are being worked on in AI fall under the supervised learning category right now. Like I said, research is always ongoing. Every day something changes, but that's where we are.
So we have 5 more minutes. I want to check questions in the room. We have one from Michael, we have one more down the table, and then we have the best 2 online. So should we take the lady at the end, if you could introduce yourself and where you're from?
I'm Deputy UN Global Policy.
Oh, great! Hey, was I accurate about what I said?
I'm only a lowly intern. It seemed to.
Okay, good. All right. Please don't go back and be like, she was spreading false information.
No, I will say two shout outs.
Oh, great. Okay. Yeah.
My question is related to the beginning of your presentation when you mentioned we're about halfway between strong AI and weak AI, and you said something to the effect of researchers are starting to design systems which remember some information. What do you mean by remember?
Good question. So, like I said, so there's computer memory in the way that we all know it. Like everyone's laptop here has memory associated with it. You can buy more memory for your computer. That's a much more technical term. It just refers to data storage. Now, when you talk about memory in terms of artificial intelligence, it's more about being able to store information, but in a specific context. So there's a difference between storing, let's say we have the sentence, the dog jumps over a tall box, right? So let's say that's the sentence we have. If you stored it in a traditional way, it's just going to literally store that entire sentence. It's not going to know what it means. It's not going to know any associations between those words. It's just going to store that sentence and recall it later if you need it to be recalled. Memory for AI is about being able to understand what that sentence means. So when I say the dog jumps over the tall box, you need to know that tall is referring to the box and not to the dog or to the word the, you know what I mean? Like all those relationships that go between it. That's what I mean when I say memory. And also, I mean memory in the sense of knowing what kind of world it exists in. So let's say you have an algorithm and you're trying to get it to predict pictures of cats versus not cats. If I show it a picture of a neon blue cat, it's going to tell me that that's a cat. But you and I know that those don't exist, so that's not a real cat. It's not necessarily going to be able to know about the broader world and have that kind of memory to be able to tell you, like, this isn't a real cat then, you know? So that's what I mean when I don't know if that was helpful, but yeah, that's what I'm talking about. Cool, I'm so glad you're here.
So one more from the online, yeah.
Okay. So and I apologize if I'm mispronouncing the name. Josie is asking, taking into account the current situation with available skills and other constraints, what do you think are the most feasible areas of implementation of AI for development over the next 2 years?
I would say any field that has data sets readily available for people to work on, because that cuts out a big chunk of the problem, which is collecting the data that you would need, right? So I can give an example off the top of my head, which people are already working on, which is mobile phone data. And when I say mobile phone data, I mean the movement of people with mobile phones. There's a lot of really good information that's packed into just the movement of someone's phone. That represents migration. So if you think about refugee populations and the directions people are going in, that's a piece of information you can pull from that and maybe predict. I talked about predicting disease spread. That's actually one way that people are looking at predicting the spread of disease, which is the way that cell phones are moving. So let's say, you know, if we had a tool like that in the time of Ebola, we would have been able to see patterns of people moving towards certain countries and been able to warn the countries like, hey, you have a huge influx of people coming in. I hope you're prepared, you know. So I would say health is probably a big one, especially with diagnostics. Again, because this data is available. So I think you'll see a lot more in health. And as far as other things in the next 2 years, I don't really know. I guess it just depends. I'm not so familiar with data sets outside of the health space because, like I said, I've done primarily health work in my career. But yeah, just use your imagination, I guess. Any data sets you can come across. We have time for
We have Michael.
Go ahead, Michael.
Michael Blackhead is my name. Yes, please. My question is based on development of the capabilities.
Yes.
Computers started out with a diode, the vacuum tube diode, about maybe 80 years ago.
Yeah.
Anyhow. And the principle was binary. 40 years ago, we had the transistors, and solid state, which allowed more to be put on smaller areas.
Yeah, like the hardware was changing.
And then 40 years ago, there was this vision of the biocomputer, which was the dream was that the computer processors would be made from organic material. But I think that died somewhere when they considered infection germs. Now we still had again the binary into the 8-bit byte, and I think we might have moved to the 16-bit byte. Now where we are now, we have very small processors, and I don't think we can go any smaller. My question is, since AI is demanding so much from processors,
Yes.
is there any kind of research that can be done to find a way outside of binary to actually develop processors?
Yes, there is. I actually saw an article just the other day that I don't remember which Chinese company, I want to say Baidu, just announced that they created a chip, a processing chip, designed specially for AI applications because of the sheer amount of processing power, as you said, it requires to be able to run these algorithms. So there is research ongoing in that because the field as a whole has recognized that this is something that's going to be a problem eventually. You know, we're going to run up against it. And we will be making strides. I would say that's actually probably the easier side of research in terms of creating the hardware. The harder side is probably more the algorithms that come with it. And like I said, getting to a stronger AI state. The diagram that I showed between the strong and the weak AI, the line was halfway in between. I think that's halfway in between the diagram, but in terms of, you know, how far away are we, I would say realistically, it's probably more like a third along the way rather than fully. So you don't have to worry about robots killing you yet. That's not going to happen tomorrow. Don't worry.
So I know we're at time. I went to the World Science Festival this year, and there's a wonderful talk on teach your robots well. Teach them the right things, teach them well, teach them morality, teach them ethics, so that they won't come out to kill you. I will share a link to that talk as well, so you have a sense of what is happening. Neural networks is actually, it's changing. There are other people who have changed the way that AI can also start computing. So the mark that you saw of here were actually decades away from the killer robot. We actually may get there faster because there are innovations happening in different ways. As we understand our brains better, we're going to be starting to program better as well. But what I wanted to do was actually hand over to Ben to say the final words and the big thank you, and also thank you also for coming today. Ben, you have the last word.
First of all, a big thank you. Just a call to action for all UNB colleagues. We have our call for proposals out for the Innovation Fund. If you have an idea, hypothesis that you're sitting on data sets, or you might access third-party data sets that can prove your work, then please come forward with a solid hypothesis. Not forgetting we're not a research institution. That data needs to add value to the user, be it inform policymaker decisions or add value to users as in, for example, direct citizens. Just to give you an example though, we have vast amount of satellite images in our scoping opportunities for using AI for biodiversity conservation. We have a number of drone initiatives where we're looking at AI. We just, and this was led by the Sustainable Development Cluster, have a process where usually analysts, so colleagues like us, go through national planning and see to what degree they align to the SDGs, and that together with IBM has largely been automated. So there are parts of our jobs that are actually done by machines in a more efficient way, opening up space and time for us. So just a call for action, consider applying for the Innovation Fund, but it needs to be very strong outcome-based. And it can also focus on designing infrastructure for ethical AI with government partners. That's another major mandate of our organization, looks at governance. And then another invitation, we're looking at AI today. It's linked to human behavior if you want to inform better decisions through better data. The latter part of that, the human decision-making, we're having an event on Friday with Professor Dan Ariely. It's at 1:15 at the Secretariat, Conference Room 7. He's a fantastic speaker, super provocative in the positive sense thinker. So hope to see you there. A big thank you.
Thank you, everybody. Thanks, guys. One last thing. I don't know if anyone from ITU here, but ITU just hosted a huge, yes, you, there we go. You guys just hosted the AI for Good Summit 2 months ago in May. I had to miss it because I was teaching, but I heard it was awesome. And they have a bunch of resources online, so go check it out if you want to learn more.